Okay, this is functionally, whoopsies, I'd rather go with a color like this. Rotational kinematics. Cases where we have constant angular acceleration. Okay, so we actually start from the same point because I'm going to go through and derive the equations. So for that, we have omega is d theta dt, and we have alpha, by definition, is the derivative of omega with respect to t. So we're going to use that second one and start from there. So if we rearrange it and alpha is constant, then we have alpha dt is d omega. If we integrate both sides from some initial to a final point, then we're going to have from omega initial to omega final and d omega. I'm actually just going to call that omega for the final point. Then you're going to get alpha times t equals omega minus omega initial. So we get kinematic equation number 1. Omega is equal to omega initial plus alpha times t. That looks awfully familiar. It's basically just a swap of symbols from what we knew for linear motion. It's the same idea. All right, carrying on from there, we're going to use the second equation. Omega is d theta dt. Well, we can use the equation we just found for omega. So we'll have omega initial plus alpha times t is d theta dt. All right, integral from 0 to t of omega initial plus alpha t dt equal to integral from theta initial to wherever we end up of d theta. That's going to look like omega initial times t plus 1/2 alpha t squared equals, and this is just theta minus theta initial, which is our delta theta, our change in position. And again, this looks really familiar. We had an equation that was the change in position is equal to the initial velocity times t plus 1/2 the acceleration times t squared. We had something like that for linear motion. So here we've got our equation 1. Here now we've got equation 2. Okay, if you remember, the way the rest of them are done is by process of elimination. If we look at these things, equation number 1 is missing delta theta, but it has the angular velocity, initial, final, angular acceleration in t. The second one, we've eliminated omega final from it. So what have we got left? Well, that's 2 of the 5 symbols we've got to deal with: delta theta, omega final, omega initial, alpha, and t. So we're going to go for equation 3 as, I'm going to make a quick copy of this. We'll pull it down there for the moment. All right, so to get equation 3, we're going to have to go and solve one equation for omega initial. So omega initial is equal to omega final minus alpha times t. We're going to substitute this into equation 2. So now we're going to get delta theta is equal to omega times t minus alpha t squared. That's just distributing the t, and then a plus 1/2 alpha t squared. And that will give delta theta is equal to omega t minus 1/2 alpha t squared. Okay, we are coming right along. This is going to be our equation number 3 now. Okay. Equation 4. Not too much worse than what we've just done. We're going to solve one for alpha and substitute it into 2. So if we solve that for alpha, we'll have omega minus omega initial over t gives us alpha. If we substitute that in, we're going to have, I still want to leave a little bit of space here, we're going to have delta theta equals omega. That looks too much like a W. I really prefer to make the omegas a bit more curly. Omega initial times t plus 1/2 omega final minus omega initial over t times t squared. All right, you notice there's a cancellation in the t. That's always nice. All right, I'm going to move these along with us as we go. Okay, next line of algebra. Delta theta is equal to omega initial t plus 1/2 omega final t minus 1/2 omega initial t. Simplifies to 1/2 omega final t plus 1/2 omega initial t. And that gives us our fourth equation, which is the change in position is 1/2 omega final plus omega initial times t. Okay. We've got 4 of the 5 kinematic equations recovered. And you notice they're still continuing the pattern, which means you can probably guess what the last one is going to do. So here's what we've got so far. Move it down. And we need to eliminate time for the last one. So we will solve 1 for t, substitute into equation 2. All right, so let's see. That's going to be omega minus omega initial over alpha gives us t. And substituting into 2, delta theta is omega initial t plus 1/2. Let's see. I need the alpha still. And then we'll have omega final minus omega initial over alpha and square it. This one does take a bit more work to finish the algebra because we're going to have to multiply out that omega minus omega I. All right, so omega it plus 1/2. There's going to be a bit of a cross cancellation with the alpha. I'm not going to handle that quite yet. I'm going to instead cube the whole thing out, or not cube, square the whole thing out. So omega final squared minus 2 omega final omega initial plus omega initial squared all over alpha squared. All right, now we've got a good point. We'll cancel out some alpha. Okay. Let's see. Oops. I made a boo-boo. All right, well, mistakes are bound to happen. Let's fix it. So what do you notice I did wrong? I still have a t. So let's back up a moment. One of the nice things about working electronically is I can come back in and move things around much more easily than I normally could. All right, so this would have omega minus omega initial over alpha, and then I'll move this back in. And we'll do much the same thing with the bottom. Let's make a little bit of space. I'll probably be able to bring this back. All right. So now I've got, let's see, omega initial times omega final over alpha minus omega initial squared over alpha. Okay. Actually, I don't think I will be moving that back in. We're almost to the last step. This is next to last. omega initial omega over alpha minus omega initial squared over alpha plus, let's see, omega squared over 2 alpha minus omega final omega initial over alpha. The 2 cancels in that middle group. And then omega initial squared over 2 alpha. All right, first things first. This whole term exists as a positive and a negative. It cancels. How awesome. All right, from there, I think the next thing I'm going to do is multiply it through by 2 alpha to get it on to the other side. So 2 alpha delta theta, and then it will be equal to minus omega squared times 2, I guess, plus omega squared plus omega initial squared. Last step. All right, a minus omega initial squared plus omega squared, that's just going to be a minus omega initial squared, so we get 2 alpha delta theta is equal to omega final squared minus omega initial squared. And that completes our set of 5 kinematic equations. You don't, strictly speaking, need to know how to find all 5 of these. I would suggest that you know how to find the first 2 because they're handy, and then memorize a couple of the remaining ones. You don't necessarily need to know all 5 of them off the top of your head. Although I do admit, it is handy. Okay, the other thing is you don't really have to memorize any of these if you still remember your kinematic formulas from back when we were doing kinematics around chapter 2, chapter 3. And the reason is, I'm sure you've noticed at this point, every single symbol is just a straight up replacement. X is replaced with theta, or R is replaced with theta. V is replaced with omega, and A with alpha, and then the T isn't even changed. So it's a pretty easy set of equations to remember, and they have pretty much the same uses. So the same rules apply. If you have only one of these equations available to use, you are looking for the right equation, the one that has only one unknown in it, while all the rest of the quantities are known quantities. So if you happen to know what omega initial T and alpha are, you're probably going to be looking at something like omega final or delta theta. You're going to be looking for one of those possibilities. Anyway, that's what you're going to be looking for. Try and figure out what symbols are given, and then which equation is only missing one of the given quantities. All right, I will summarize that again briefly, and then we will wrap this one up. Okay, so reminder for kinematic problems. You are looking for the equation. Well, first, examine the givens. Look for an equation that is missing only one symbol. There's only one thing that you don't have as a given. Solve the equation for what you want and plug in. And that should pretty much do it for these types of problems. I would still recommend drawing a picture is almost always helpful. So please try and do that. It's a good guide to what you're doing, and even better, when I'm grading, it's a good guide to, did you do it right? Were you thinking along the right lines? So that's going to be it for this section. I'll see you next video. This one is a long one.